And this is today's LeetCode daily question. It's 783 minimum distance between BST nodes, that is binary search tree nodes. Given the root of a binary tree, written the minimum difference between the values of any different nodes or any two different nodes in a binary tree. So they have mentioned that they have given us a binary search tree, and we all know that the property of binary search tree is that we have a node, and all the nodes which are lesser than that particular node or having value lesser than that particular node are situated on the left side, and all the nodes having value greater than the value of the given node are situated on its right hand side. So using this property we can solve this question. The fact is that we know that if we want to find the difference between any two numbers, then the minimum difference will always be of two consecutive numbers. And as we want to find two consecutive numbers, we can just use in-order traversal on a binary search tree, because in-order traversal of a binary search tree is nothing but a sequence which is sorted in ascending order. So it will be a sequence of consecutive numbers, so we can just use that property of binary search tree and solve this question. So let's get started. To solve this question, first of all, what we are going to do is we are initializing an answer variable which will be pointing to int max initially, and we just have to return this answer variable. After that, we will keep a previous pointer equal to -1, which will store the previous number that we have visited, and then I will call a function called as solve, passing a root, the previous, and answer. So you may ask why we are going to follow this framework of a problem. The reason behind it is that if we can just traverse over the tree, like this is a tree given to us, and we can traverse like 1, 2, 3, 4 and 6. In this way, if we are traversing, we have to store all the nodes in a vector. And as you can see here, we have 10 raised to 5 nodes, and storing 10 raised to 5 integers in a vector is a costly operation, and it is not needed in this problem also. So what we are going to do is we are traversing using a traversal technique called as in-order traversal, and using in-order traversal we can solve this problem. So initially our previous will be -1, so no previous at all. So when I'm at 1 I have no previous, but when I'm at 2 I have a previous as 1. When I'm at 3, I have a previous as 2. When I'm at 4, I have previous as 3. And when I'm at 6, I have previous as 4. So this previous variable will change accordingly, and we will update the answer according to our traversal, the in-order traversal. So let's create a private function, if I can spell it correctly, a private function called as void solve. I don't know why I'm mistyping all this names of functions and keywords. So first of all, it will be a tree node root, then it will be a previous, and then it will be the answer. The answer will be passed by reference, and previous will be passed by reference, because we have to use it on every node of our tree, and our traversal can't just pass that particular previous value to each node. So that's why it must be passed by reference. So if we don't have root, so if root equal to null, then I can just return, I don't want to go ahead. But if we don't have it as null, then I can just call a solve function and go to the left of a tree. Okay, passing the previous and answer to it. And similarly, I can also go on the right of the tree, passing it the previous and answer. But as I've told you earlier, we are doing in-order traversal, and according to the rules of in-order traversal, our root must process at this portion. So let's write our business logic for this portion. First of all, if my previous is equal to -1, that means I have no previous. So if I'm on this position, that means I'm on 1, or for this particular tree I am on 0, then I have no previous. And if I have no previous, then I don't have to follow anything. But if I have previous, that means my previous is not equal to -1, then my answer will be equal to minimum of my answer and absolute value of my root's value minus previous. And we know that our previous will be always lesser than our root value, because previous is a node which is on the left hand side, or it is a pre-order success pre-order it's a in order predecessor of our node. So it can be on the left hand side, or for this node it can be this 3. So therefore it will be always lesser, so we don't need this abs function, and we can save up that call and save up our space and time of O of 1. And after that my previous will be equal to root value, and if I run this code it must run. Okay, let's see if it's running or not. So it's running absolutely fine, and let's try to submit it. So you may ask, what is the time complexity and space complexity of this code? So it's pretty straightforward that the time complexity of a code is O of n, because we are visiting every node, and the space complexity of this code is nothing but O of h, where h is height of a tree, and it can be O of n in the worst case if the tree is a skew tree. So you can go in that way also. So it's a pretty straightforward question, and you can solve it using 2 ways. The first way that I have suggested you was storing a 10⁵ vector, but it's not recommended way, and interviewer might ask you a optimized version, and this is the optimized version only. So it's the straightforward code, and hope you understood it. If you liked this video, then don't forget to like it on YouTube also, and share it with all your friends who are stuck upon this problem, and don't forget to subscribe the channel. Thank you very much. I'll see you in the next one.